Hi, today we're going to be doing lesson 4, session 2. We're going to be working with multiplying multi-digit numbers. Yesterday we focused on multiplying and we reviewed the area model, and then I introduced multiplying with partial products. And so today I'm going to do one more quick review of the area model, and then we're going to move into the partial product model. So we are going to be working in our workbook, pages 59 through 62. And so if you want to take out your Ready Math workbook and turn to page 59, that would be fabulous. All right, so to review, we're going to go ahead and just go over multiplying using an area model, or some call it the window method, because this area model looks similar to a window if the window had grid in it. So the first thing we do is we write out both factors in expanded form, one factor on top of the model and one factor on the side. So the problem we're doing is, what is 126 times 32? So 126 written in expanded form is 100 plus 20 plus 6. And 32 written in expanded form is 30 plus 2. So on this model wrote what I was thinking as I was doing each of these partial products in the windows or in the area model. So after we write our expanded form, then we fill in the grid by multiplying each pair of numbers. So we're going to multiply 30 first by 100, which is 3,000, then 30 by 20, which is 600, and then 30 by 6, which is 180. Then we're going to multiply 2 times 100, which is 200, 2 times 20, which is 40, and 2 times 6, which is 12. Then we take each of the partial products, making sure that we have 6 and that we didn't forget to write any. We're going to line them up by place value, so all of our ones, tens, hundreds, thousands, and then add them up to get our final value. So the last thing we do is add up the partial products from the boxes and you have your answer. So this is a review of how to solve an equation using an area model. So now we're going to go ahead and go onto page 59. So on page 59, we have the question that says this: there are 128 pens in a full box. How many pens are in 35 full boxes? So like we do every lesson, the first question we ask is, what is this problem about? So this problem is about pens in a full box. So we are talking about pens in boxes. That's what we want to know. Now, what are we trying to find out? What is the question that that we're being asked to solve? And so that is, how many pens are in 35 full boxes? And then lastly, we need to find out what is the important information. So we know that there are 128 pens in a box and that we have 35 boxes. So we know if we have 128 pens in a full box and we have 35 full boxes, we need to multiply 128 times 35 to see how many we have all together. So we're going to do the math problem. What is 128 times 35? So what I'd like for you to do right now is I'd like for you to pause the video. And while you pause the video, I want you to solve this problem using a method that you like. If you would like, go ahead and use the area model method, which we practiced yesterday. And then, but if you know a different method that you would like to use, you can go ahead and use that now. Go ahead and pause the video and then come back in a moment. All right. So now we are going to, one moment. I want to make sure that I didn't pause the video. Oh, good. All right. So now, I am not going to solve this because when we go to the next page, we're going to see a couple of different methods. So go ahead and remember what you wrote here, because we're going to check and see how you did when we get to the next problem. So go ahead and turn your book to page 60. So on page 60, we see the problem again. It says there are 128 pens in a full box. How many pens are in 35 full boxes? And then here we see the area model that the book did for us. They wrote 128 in expanded form is 100 plus 20 plus 8. They put 100, 20, and 8. And then on this side of the area model, they wrote 35 in expanded form, which is 30 plus 5. So we wrote 30 here and then 5. Then they went through and they multiplied 30 times 100, 30 times 20, 30 times 8. And then they got their partial products. Next, they did 5 times 100 and got a partial product of 500. 5 times 20 and got a partial product of 100, and 5 times 8 to get a partial product of 40. Finally, they added up all of the partial products. Instead of putting them all up and down in a line, they decided to add the rows all the way across and then add the 2 rows together. That's a different method that you can use. What you're going to use whatever is best for you. But it is a great idea. So what they did here is they said 3,000 plus 600 plus 240 is 3,840. 500 plus 100 plus 40 is 640. And then to get the total answer, you would add 3,840 plus 640. All right. Then, and I think we're going to do that over there. Now, the second modelet talks about using the distributive property to find partial products and add them. So what they do here is they think that 128 times 35 is the same as 128 times the expanded form 30 plus 5. So you could also write that as 128 times 30 plus 128 times 5 because because it's giving you the same idea. So here is a way that you could use expanded form or the distributive property to find partial products and add them. I'm going to show you a method a little bit different than this, but what they did here is I'm just going to show you how to do it all in one big long line. So they did 128 times 30. So they did first 30 times 8, then 30 times 20 because the 2's and the 10's, and then 30 times 100. Then they did 5 times 8, which is 40, 5 times 20, which is 100, and then 5 times 100, which is 500. And then they got the 2 partial, or all of these actually, are partial products. All right, let's go ahead and answer some questions that have to do with the modelets. Now, number 1 says, why is the area model divided into 6 sections? So go ahead and pause the video right now and write down why you think the area model is divided into 6 sections. All right, the area model is divided into 6 sections because there are 6 partial products. So we see down here we have 1, 2, 3, 4, 5, 6. We also down here can see that we have 1, 2, 3, 4, 5, 6. So we need to have 6 sections because there's 6 partial products. We also need to have a section for every that corresponds with the place value. So if it were 128 times 30, we would only have 3 sections because this section with the 5 wouldn't be there. But we have to account for both the 10s and the 1s, and then the 100s, the 10s, and the 1s. It all has to do with place value. Number 2, how do the 3 partial products in each multiplication equation in the second modelet relate to the 3 sections in each row of the area model? So, how does this relate to this? And how does this relate to this? Go ahead and pause your video and then come back when you think you have the answer. All right, so how they relate is that each partial product in an equation is the same as the partial product in one section of each row of the area model. So if you look down here, each partial product in this equation, 30 times 8, 30 times 20, 30 times 100. 30 times 8, 30 times 20, 30 times 100. 5 times 8, 5 times 20, 5 times 100. 5 times 8, 5 times 20, 5 times 100. So each partial product, in an equation is the same as the partial product in one section of each row. Now, if we, number 3 says use the partial products 3,840 and 640 to find the product of 128 times 35. How many pens are in 35 full boxes? So if we come up with these two final partial products, what do we need to do to those two numbers to find out how many there are in all? That's right, we just need to add them together. So 3,840 plus 640, 0, 8, 14. So there are 4,480 pens in 35 full boxes. All right. Now, would the product change if 30 and 5 on the left side of the area model were changed to 20, 10, and 5? Explain. So if we changed this instead of being 30 and 5, if we changed it to 20, 10, and 5, would it give us a different value? I don't know. Let's find out. So we're going to go ahead and make the area model. We're going to have 128, but instead we're going to have, it's going to be a big area model, but we're going to have 20, 10, and 8. 20, 10, and 5. Now, it's important to note that the total value here, what is 20 plus 10 plus 5? That's right, it's also 35. 30 plus 5 is 35. So I want you to make a prediction right now. Do you think it will be the same or different? All right, let's see if your prediction was right. 20 times 100 is 2,000. 20 times 20 is 400. 20 times 8 is 160. 10 times 100 is 1,000. 10 times 20 is 200. 10 times 8 is 80. 5 times 100 is 500. 5 times 20 is 100. 5 times 8 is 40. 2,000 plus 400 plus 160 is 2,560. 1,000 plus 200 plus 80 is 1,280. 500 plus 100 plus 40 is 640. We add those all up. 0, 18, look at that, 4,480. So we got the same answer. Was your prediction right? I want you to write right here why they are the same value. Why did we end up with the same? I'm going to tell you it has something to do with this this and this. Why are they the same? Go ahead and write that answer there. All right, if you're not finished yet, you can go ahead and pause the video. Otherwise, we're going to go on to number 5. List 2 different ways you could break up the factors 239 times 64 to find the product. Explain why the 2 ways would have the same product. So the first way we know we could do would be, we're going to keep 239 the same. So 239 times, and then we're going to break up 60. So 64. So we're going to make it as 60 and 4. So 239 times 60, and then 239 times 4. Because this number is staying the same, and we're just breaking up the 64. But we could also break up the 239. So we could say 200 times 64, 30 times 64, and 9 times 64. Because here we are leaving the 64 the same, but we're expanding the 230 and the 9. So either of these ways would work. But what you're doing is we're taking and we're leaving one factor the same, and then we're using distributive property to put the other number into expanded form and breaking it up to make it a little bit easier. So looking back at your try it, so way back here when you did this problem here, many of you probably used area model. And then we've talked a little bit about partial products. I'm going to show you a little bit more when we get to the next page. As it stands right now, which model or strategies do you like best for multiplying a whole digit, multi-digit whole digit numbers? So you're either going to say, I like, and then you're either going to choose area model best, or you're going to choose I like partial products best. And then you're going to say because. So whichever one you like best, you're going to choose that, and then you're going to tell me why. So go ahead and pause the video and finish that answer right now. All right, we're going to move on to the next page, to page 62. On page 62, I'm going to show you how to solve this problem using partial products a slightly different way than we have been doing it. So I'm going to choose, we're going to use, this problem actually has 2 problems that we need to do, so let's go through and talk about that. So first it says, find the product 120 times 25 times 40. So then it says, does it matter in what order you multiply the numbers? Explain. So does it matter how we multiply these? No, because with multiplication, no matter what order you do your multiplication in, you're always going to get the same product as long as you're always multiplying. So you could multiply the 25 and 40 first. You could multiply the 120 and 25 first. You could multiply 120 times 40 first. For today, I'm going to say, let's go ahead and multiply 120 times 25. So to do that, and if we're using partial products, I'm going to do it like this. So I'm going to first deal with this 5 in the ones place. So my first partial product is going to be 5 times 0, because there's a 0 in the ones place. Then I'm going to do 5 times 20, because this 2 doesn't mean 2, it means 20. So you're going to do 5 times 20. then 5 times 100. And I'm going to go ahead and solve those right here. So 5 times 0 is 0, 5 times 20 is 100, and 5 times 100 is 500. Now here's what I like about this. The 0, the 20, and the 100 are going to stay the same. But instead of starting with 5, we're going to start with 20, because this 2 is in the tens place and it means 20. So we're going to say 20 times 0, 20 times 20, and 20 times 100. All I did was do this 20 times 0, 20 times 20, 20 times 100. And then I solve for each of those partial products. 20 times 0 is 0. 20 times 20 is 400. 20 times 100 is 2,000. And then I'm going to add up all of these partial products to get a final, my first product, which is 0, 0, 1 plus 5 is 6, 6 plus 4 is 10, 0, carry the 1, 3. So 120 times 25 is 3,000. But I'm not done yet, because all I've done so far is multiply 120 times 25. So now I need to multiply my product here, which is 3,000 times 40. Now what's nice about this is I don't have to do any partial products, because the 0 is in the ones place, so I don't need to do that, because 0 times 0 is 0, and then even 0 times 3 is 0. So I'm going to do, what is 40 times 0? 0. 40 times still 0, 0. 40 times still 0 is 0. And then 40 times 3. Oh, I forgot to add my zeros though. So 40 times 0, 0. 40 times 0, 0. 40 times 0, 0. 40 times 3 is 120. And then I go in and I put in my comma. So the product of 120 times 25 times 40 is 120,000. All right. Let's take a break from that, because that was a beefy problem. So now we're going to go to number 8. Number 8 is very similar, is what we just got done doing. The question says, find the volume of this rectangular prism. How is this problem similar to problem 7? So we're going, when we multiply for volume, we do length times width, or this is width, so length times width times height. So if you look, we have 120 times 25 times 40. Where have we seen that problem before? 120 times 40 times 25. If you didn't recognize it, we just did this problem up here. But how is this problem similar? It uses the same factors. What's cool, up here, you're just being asked to multiply some numbers, but they don't mean anything. Down here, what's super cool is they're asking you to find out how many cubic centimeters fill this cube, this rectangular prism. So you know that there are 120,000 cubic centimeters. That fill this rectangular prism. So we, to find the volume, we multiply that length times width times height. So it's the same problem, but now instead of it just being random numbers, we're using it to actually solve a real life problem to find out how many cubic centimeters would fill this rectangular prism. All right, for number 9, this is the last problem you're going to do with me today. You're going to, it says a library bookshelf holds 156 books. There are 15 bookshelves in a certain section of the library. How many books can the library place on these bookshelves? Show your work. So you're going to multiply 156 times 15. I want you to use the method that you like the most. So you can use area model, you can use partial products, or if there's another method that you know, you may use that method. I want you to pause the video and solve using your favorite method. And then I'm going to, I will do it with partial products in a moment so that I can show you how to do partial products just one more time. All right. So we have 156 times 15. So first I'm going to look at the 5 and I'm going to say, okay, 5 times my 1s is 6. 5 times my 10s is 50. And then 5 times my hundreds is 100. And then I'm going to solve each of those for each of those partial products. 30, 250, 500. Then I'm going to do my 10, excuse me. My 10's place, there's a 1 in the 10's place, so it's going to be 10 times 6, 10 times 50, and 10 times 100. 10 times 6 is 60. 10 times 50 is 500. 10 times 100 is 1,000. Then I'm going to add all of my partial products together to get my final answer. 0. 3 plus 5 is 8. 8 plus 6 is 14. 2 plus 1 is 3, plus 5 is 8, plus 5 more is 13. The answer is 2,340 books. And with that, we are done with our lesson for today, and you can move on to your independent practice.